example 2 of graphing without using the y equals function on your calculator. So the first thing that we are going to do is use x is equal to negative b divided by 2a to find the axis of symmetry. So my a value on this problem is the imaginary negative 1 in front of the x, and my b value is 4. My c value is 5, but I'm not going to write that down because it's not necessary. So it's going to go negative my b value, which was 4, divided by 2 times my a value, negative 1. And let's simplify this. That becomes negative 4 on the top divided by negative 2 on the bottom, which gives me positive 2. So we have an axis of symmetry at x is equal to positive 2. And I'm going to go ahead and draw that vertical line. I like to make it dashed so I know that that's actually just the axis of symmetry, and it's right there. So now that we have the axis of symmetry, we're going to take that original equation that's right there and take that x value and plug it in place of both of them. So I would have y is equal to negative my x value squared plus 4 times my x value plus 5. And I'm plugging in that positive 2 right there. So let's go ahead and plug that into our calculator. So negative 2 squared plus 4 times 2 plus 5. I hit enter. That gives me positive 9. So that means my y value of that vertex is at 9. So I've got x is 2, y is 9. My vertex point is at 2, 9. So now I'm going to take that point and plot it on my axis of symmetry. Okay, now that we've got the axis of symmetry in your vertex point, now we are going to be looking for the x-intercepts. So what you're going to do now is take the original problem, y is equal to negative x squared plus 4x plus 5, and we are going to factor this trinomial. Now you can get rid of the y equals part because it's not really necessary. We just care about this. The only thing that's different is we have never dealt with that negative sign in front of the x squared. So really we just kind of need to get rid of it. And how we are going to do that is to factor out a negative 1, just like we did when we were doing greatest common factors. I just divide it out and then put it on the outside of the parentheses. That becomes x squared minus 4x minus 5. And now that we've got a normal trinomial inside the parentheses, all we are doing is factoring that like we always have. We can go ahead and put our x's inside the parentheses. The numbers that multiply to give me negative 5 could be one of those, but I'm choosing the second pair because those add to give me negative 4. So plus 1 and minus 5. Now that I've got my thing factored, I'm going to say x plus 1 equals 0 or x minus 5 equals 0. This one is just a one-step equation. I subtract the 1 from both sides and get x is equal to negative 1. Or for the other one, I add 5 to both sides of the equal sign and get x is equal to positive 5. So keep in mind that those are x-intercepts at negative 1 and 5. And those are both 1, 2, 3 units from the axis of symmetry. So that does make sense. Okay, so that's all the most basic parts. Now we've got to do the find some additional points to go ahead and plot. Now I always kind of want to make sure I've got the y-axis. We plugged in this x value of negative 1. We've got that one. We need an x value of 0 and an x value of 1. And that'll give me 3 points on this side of the parabola. That's probably going to be good enough. So I'm going to deal with x equals 0 and x is equal to positive 1. So I'm taking the original equation. Let me just rewrite it over here so you can see it. And we are just going to plug in that x value. So y is equal to negative 0 squared plus 4 times 0 plus 5. If you simplify that, it gives you 5. So the first point that we are going to be putting down is 0, 5. For the other one, I've got x is equal to 1. So I've got negative 1 squared plus 4 times 1 plus 5. So let's go ahead and simplify that inside the calculator. So negative 1 squared plus 4 times 1 plus 5. That gives me positive 8. So that means that I've got a point at 1, 8. Okay, so let's plot those and then see if that's enough to see our picture. So I've got a point at 0, 5. I plot that one. And I've got one at 1, 8. So we're going to the right one and up 8. And I would say that that probably looks like we've got a pretty good parabola. As long as it's going through the y-axis and you can see the x-intercepts, then that's probably good enough. Now for the next part, instead of plugging in more numbers, I'm just going to reflect my points across the axis of symmetry. So we had a point that's 1 to the left. Let's put a point 1 to the right. This one is 2 to the left, so let's go 2 to the right. And then the other one we already have. So now I can take my points and I'm going to connect them with a curved line. Just like that.